Now, in case of P block, we will discuss here chemical property. We will discuss here chemical property of group. We can say that 13. Here, first topic is completed. Which one? Oxidation state and trends in chemical reactivity. Here means this topic is already completed. So now next one is reactivity towards oxygen. Here we will discuss things related with respect to oxygen. So see, all member when heated in O2 form oxide. So whenever group 13 related elements are heated with O2, then it will form oxide. So there are mainly two types of oxide. So one we can say that monoxide and second one is dioxide. Whenever oxygen will combine with group 13 related element, here means oxide will form, and after formation of oxide, here means either monoxide or dioxide will form. The general formula of monoxide is MO and dioxide is MO2 respectively. Clear? MO2. The dioxide is again we can say it MO2 respectively. Here silicon oxide only exists at high temperature. Silicon oxide will exist. Silicon oxide only exists at high temperature. Clear? Now, oxide in higher oxidation state of elements are generally more acidic than those in lower oxidation state. Oxide in higher oxidation state of elements are generally more acidic than those in lower oxidation state. The dioxide, just like this one, the dioxide means CO2, SiO2, germanium oxides are acidic in nature. Clear? The dioxide, it means CO2, SiO2, GeO2 are acidic in nature, whereas SnO2 and PbO2 are amphoteric in nature. Whereas SnO2 and PbO2 are amphoteric in nature. Now, so these are we can say an example of dioxide. Now, among monoxide, monoxide में carbon monoxide is neutral. Germanium oxide is distinctly acidic, whereas SNO and PbO are amphoteric in nature. Here we can say that SNO and PbO are again we can say that amphoteric in nature. Here हुआ कि नहीं? तो dioxide है ना? These are we considered complete information. So these are again we considered complete information. Whenever group 13 related element will combine with we consider here is oxygen. Clear? Now next chemical property is reactivity towards water. The next chemical property reactivity towards water. So carbon, silicon, germanium are not affected by water. Carbon, silicon, germanium are not affected by water. Sn decomposes steam to form dioxide and hydrogen gas. Sn decomposes steam to form dioxide and hydrogen gas. तो Sn plus water heat किया तो SnO2 plus hydrogen will form. Now lead is unaffected. Here we can say that lead. So lead is unaffected by water, probably because of a protective oxide film formation. Lead and lead. The lead is unaffected by water, probably because of a protective oxide film formation. Clear? If you are comparing, see this is carbon, silicon, germanium, tin and lead. So here we can say that one is non-metal and then after we can say that here inert pair effect will be there. Clear हुआ? So now we will discuss reactivity towards halogen. The reactivity towards halogen मतलब here means X minus 1 will be there and this one is M plus 4. तो combine होके क्या कर देगा? MX4 will come. Here general formula will be either MX2 or we can say that MX4 will be there. So general formula will be either MX2 or MX4 will be there. Except carbon, all other member react directly with halogen under suitable condition to make halide. Except carbon, all other member react directly with halogen under suitable condition to make halide. So most of MX4 are covalent in nature. Clear? The central metal atom in these halide undergoes sp3 hybridization and the molecule in tetrahedral shape. Clear हुआ? Exceptions are SnF4 and PbF4 which are ionic in nature. Clear? Here we can say that after formation of halide, so nature may be either we can say that acidic or we can say that basic or amphoteric in nature. Similarly, we can say that on the basis of bond, your material will be either covalent or we can say that ionic in nature. Clear? So now PbI4 does not exist because PbI bond initially formed during the reaction does not release enough energy to unpair 6s2 electron and excite one of them to higher orbital to have 4 unpaired electron around lead atom. So this is reason. Here we can say that ये क्या है? So this one is again we can say that reason. Here PbI4 does not exist because PbI bond initially formed during the reaction does not release enough energy to unpair 6s2 electron and excite one of them to higher orbital to have 4 unpaired electron around lead atom. और इसी को आप क्या बोल सकते हो? Here we can say that inert pair effect. Here we can say that inert pair effect. अब मैं ऐसा बोलूं कि PbX4 is possible और PbI4 is possible but PbI2 is not possible. So PbI2 is not, see PbI4 is not possible. So due to presence of inert pair effect. So whenever we can say that, what is inert pair effect? The effect due to which if our element will be stable, effect due to which if our element will be stable less than 2 number as compared to its maximum oxidation state, तो उसको बोलते हैं inert pair effect. So now heavier element like germanium and lead are able to make halide of formation MX2. ठीक है? Stability of dihalide increases down the group considering thermal and chemical here stability. So GX4 is more stable than GX2. GX4 is more stable than GX2, whereas PbX2 is more stable than PbX4 is there. So except CCl4, other tetrachloride are easily hydrolyzed by water. Except CCl4, other tetrachlorides are easily hydrolyzed by water because the central atom can accommodate the lone pair. Central atom can accommodate, here we can say that lone pair of electron from oxygen atom of water molecule in d orbital. Clear? Here we can say that except CCl4, other tetrachloride are easily hydrolyzed by water. So because the central atom can accommodate the lone pair of electron from oxygen atom of water molecule in d orbital. Clear हुआ? So whenever we can say that देखो अभी SiCl4 है, तो this is SiCl, Cl. अब मैंने यहाँ पे ले लिया वाटर मॉलिक्यूल, तो जैसे ही आप वाटर लेते हो HOH, ये गया, तो here means what will happen? Here Cl, and here we can say that OH will come. तो Cl is substituted with the help of OH. उसके बाद फिर से क्या आ जाएगा? Again we are taking here means HOH. तो फिर ये HCl गया. Here means what will happen? Here silicon, Cl, and then after OH, and then after we can say that OH will come, and this is again we can say that Cl and Cl. Again we are replacing out these two Cl. So whenever we can say that hydrolysis will be done, whenever or in another way, if hydrolysis is completed in case of silicon tetrachloride, here we can say that silicon tetrahydroxide will form, and another name of this one is again we can say that silicic acid. जैसे ये सिलिकॉन है, OH है, OH है, OH है, OH, इसको क्या बोलते हैं? तो दिस वन इज नॉर्मली नोन एज सिलिसिक एसिड, या तो आप इसको ऐसा कर दो SiOH4. तो दिस वन इज नथिंग बट इट इज नॉर्मली नोन एज सिलिसिक एसिड. So this is complete information related with respect to chemical property, correct? Now, in case of P block, so this is important trend. So what is important trend? An anomalous behavior of carbon. Clear? Important trends and anomalous behavior of carbon. So like first member of other group, carbon also differ from rest of the member of its group. Like first member of other group, carbon also differ from rest of the member of its group. It is due to its smaller size. तो कौन कौन सा smaller size, higher electronegativity, higher ionization enthalpy, and unavailability of the d orbital. Clear? So why carbon is unique? तो carbon is unique तो due to we can say that number one, एक तो आपको स्मॉलर साइज बोलने का, सेकंड वन इज हायर इलेक्ट्रोनेगेटिविटी, थर्ड वन इज हायर आयनाइजेशन एंथैल्पी, एंड फोर्थ वन इज अनअवेलेबिलिटी ऑफ d orbital. In case of group 14, carbon is unique on the basis of these four parameter. Which one? Smaller size, higher electronegativity, higher ionization enthalpy, and unavailability of the d orbital. Clear? Now, in carbon, see, in carbon S and P orbitals are available for bonding. In carbon, only S and P orbitals are available for bonding, and therefore it can accommodate only 4 pair of electron around it. Clear? So this would limit the maximum covalence to 4. Whereas other member can expand their covalence due to the presence of d orbital. Clear हुआ कि नहीं? In carbon only S and P orbitals are available for bonding, and therefore it can accommodate only 4 pair of electron around it, and this would limit the maximum covalence to 4, whereas other member can expand their covalence due to the presence of d orbital. Clear? In case of carbon, देखो कार्बन में क्या होता है, d orbital नहीं होता है. While see in same group, if atomic number will increases, here we can say that d orbital will increase. Clear हुआ कि नहीं? तो here we can say that d orbital, जैसे देखो अभी ये कार्बन है, ये सिलिकॉन, जर्मेनियम, टिन एंड लेड, तो कार्बन में Z is equal to 6. So 1s2, 2s2, 2p2. Here 1, 2, 3. तो ये 1, 1, 1, 1. एक इलेक्ट्रॉन यहाँ पे जम करा दो. तो how many orbitals are there? 1s and 3p. तो here total number of orbitals are 4. Clear? So carbon also has unique ability to form p-pi multiple bond. Carbon also has unique ability to form p-pi multiple bond with itself and with other atom of small size and high electronegativity. Clear? High electronegativity. So for example of multiple bonding are C double bond C, C triple bond C, and C double bond O, C double bond S, and C triple bond N. The heavier element do not form p-pi bond because their atomic orbitals are too large and diffuse to have effective overlapping. Clear? Here we can say that heavier element, मतलब सिलिकॉन की बात चल रही है ना, या other element. The heavier element do not form p-pi bond because their atomic orbitals are too large and diffuse to have effective overlapping. Clear? Now carbon atom have tendency to link with one another through covalent bond. Here which bond is there? Covalent bond to form chain and ring. Here means chain will form as well as ring will form. So this property is known as catenation. So this property is nothing but it is normally known as catenation. So this is because carbon-carbon bonds are very strong. Down the group, the size increases and electronegativity decreases, and thereby tendency to show catenation will also decrease. It means if we are going above to below, if we are going above to below, the catenation property will decreases. See, in case of chemistry, catenation property will be maximum for carbon, and due to catenation property, one carbon will combine with another carbon, and here we can say that up to 210 carbon molecule will join with each other. Up to 210 carbon molecule will join with each other, and then after here means one bulky molecule will form here. Clear? तो catenation का definition, तो पूरे chemistry में catenation property is maximum. पूरे chemistry में catenation property is maximum in case of carbon, and if you are going above to below, here catenation property will decreases. If we are going above to below, so catenation property will again we can say that decreases. So this can be clearly seen from bond enthalpy value. Bond enthalpy value. So bond enthalpy is represented with the help of H. This is thermodynamic parameter. The order of catenation will be carbon, silicon, germanium, and tin is there. Clear? So PB does not show catenation. Why PB does not show catenation? Because see, if we are going above to below, here means maximum d orbitals are there. Maximum d orbital. And another reason is, here we can say that, see, due to presence of inert pair effect. Due to presence of inert pair effect. Clear? So now, due to property of catenation and p-pi bond formation, carbon is able to show allotropic form. Clear हुआ? Due to property of catenation and p-pi bond formation. Clear? What will happen? So carbon is also show allotropic form. So now we will discuss here means allotropes. अब देख, कोई बोले catenation, p-pi bond, so how we can explain p-pi bond formation? So देखो, you know, this is molecular orbital theory. यहाँ पे देख px है, py है, pz. The energy of px, py and pz will remain same. Symmetry of px and py will remain same, and pz is different. In case of px and py, energy and symmetry both are same. Pz, so here we can say that pi bond, and here we can say that sigma bond will be there. Here means pi bond, and then after we can say that sigma bond will be there. Clear? तो चलो यहाँ पे pi 2px, pi 2py, and then after sigma 2pz is there. Pi 2px is equal to pi 2py. तो अब देखो इधर पे क्या होगा? Due to this reason, in case of px and py, here we can say that pi bond formation will be there. Here pi bond formation will be there. Clear? अब आता है allotropes. तो what is meaning of allotropes of carbon? तो देख allotropes का मतलब chemical constituents are same. Allotropes मतलब chemical constituents are same, but due to difference in arrangement, properties are different. Clear? What is allotropes? The allotropes of carbon. Here chemical constituents are same, but due to difference in arrangement, here properties are different. Clear हुआ कि नहीं? उसको हम लोग बोलते हैं allotropes. तो see, here carbon exhibit many allotropic form, है ना? Both crystalline as well as amorphous. तो crystalline is water soluble, amorphous is water not soluble. अब आता है diamond. Here me diamond and graphite are two well-known crystalline form of carbon. Diamond and graphite are two well-known crystalline form of carbon. In 1985, third form of carbon known as fullerene was discovered by HW proto, E smiley and RF curl. Clear? In 1985, third form of carbon known as fullerene was discovered by HW proto, E smiley and RF curl. For this discovery, they were awarded the Nobel Prize in 1996. Clear हुआ कि नहीं? तो here means one of the most important definition is catenation. एक definition catenation है, तो catenation मतलब combining capacity of one carbon with another carbon to form long chain. So this one is nothing but it is normally known as catenation. And second one catenation के बाद allotropes. तो allotropes का मतलब chemical constituents are same but due to difference in arrangement properties are different. So now we will discuss in case of carbon, graphite, diamond and then after fullerene. Clear?